Hello, today we are going to see how to use EFS, how to create a simulation and how to analyze the results. First of all, we have to log in on the KRUCH SIDOS platform. Once on the simulation panel, we go to the create button. And here we have all the parameters that we can configure on the simulation. We will set a name and an email to get a confirmation once the simulation is finished. For the comments, in this simulation we want to simulate a new vehicle, and this vehicle will run in line 1 in a frequency of 5 minutes. This is the scenario that we are simulating today. Simulation parameters that can be changed: chopper voltage, maximum voltage of the infrastructure when the vehicles brake, and other settings as acceleration, brakings or stopping times. We will create a worst case scenario, just simulating the maximum wear of the contact wire, that is 30%, maximum wear of the rail, and the maximum wear of the return rail. For creating a vehicle, we go in the vehicle aggregation, click on the create button and set the parameters of this vehicle. This vehicle will be higher, will have a heavier empty mass, a heavier rotating mass and a heavier passenger load. We know that the traction power will be higher and the traction current will be higher. This is why we are simulating this vehicle in our infrastructure, to see if our infrastructure supports these higher demands, current demands. Once the vehicle is created, we go to the timetables, and in line 1 we need to set this UK light rail vehicle, this new vehicle that we have created. We also set in a frequency of 5 minutes. And now we have in light 1 this new vehicle running in a frequency of 5 minutes. Other parameters that we could change are the transformer parameters, secondary voltage, power or short circuit voltage. The track sections, we could change the catenary system type of each part of the network or the rail type, and the same for positive feeders. On the switches, we can change the configuration of the network. So if we are having a network like this, to create an N-1 scenario, it is as easy as disconnecting one substation. N-1 scenario means disconnect a full substation, so just clicking on these boxes we can disconnect substations. For the coupling switches, also the same, we can change the configuration of the network. For example, this switch number 2 that is open, we can close it to simulate different configurations. Once we have all the parameters configured, we click on the run button and we go to the simulations panel. Here now we see that our simulation has started running. Okay, let's analyze the results of a simulation. We go to the I button, and the first thing that we see is the loads of the substation. So in green we can see substations that are not overloaded, but we can see one substation in red that has a 110% load, that is overloaded. We also depict in yellow substations that are almost overloaded, because we have to keep an eye on them. Other results that we can see very easily and graphically in a map are the minimum voltage of the infrastructure. So in this case, we can set a 500 volts and we see where our voltage is below to 500 volts on our infrastructure. This means that in these 3 sections we probably will need a reinforcement wire on the catenary. We can also see maximum voltage of the return rail, maximum rail earth voltage that is produced in here, but the maximum is 33 volts. There is no problem in this case. Can also show the maximum current of the catenary, maximum temperature of the contact wire, and where the energy losses are produced. On the tables we can see easily and where we have the problems, the transformer loads, the third rail, and positive and negative feeders. Transformer loads. Click inside and we see that substation I has a 110% overload. For the positive feeders, we can see that the overloads are produced in the RMS 280 seconds, not on the circuit break here or on the RMS 15 minutes. And the infrastructure summary, we can see that we have 2.6 kilometers of voltages below 500 volts. So we have quite a problem here. For the graphics, which graphics can we show? We will load the I transformer graph, and we can see here all the load diagrams of the transformers. We can see that all the transformers that were not overloaded are here. Then, if we remember, we had substation G that was in orange, almost overloaded, and substation I that was overloaded. So we can see the loads, all the transformers. The energy balance, we show the energy that all the substations are delivering and where this energy is used. How much energy is lost on the catenary and the return rail, and how much energy is used for the vehicle. If we go in further detail, we can even see how much energy is fed back into the grid, so it's reused when the vehicles brake, and how much energy is lost, is burned on the braking resistors. The substation side, we also can see how much energy is delivering each substation, which is the vehicle energy, so the energy per kilometer of each vehicle type, in this case 5.92 kilowatt hour per kilometer. And then the distance, well, the vehicle graphs. Start for the distance. We also have the speed for each second of the vehicles, which is the voltage of the vehicles. We also can choose different vehicles in here. We see other speeds, other voltages, the current, the vehicles, when the vehicles accelerate, and when the vehicles brake, that the current is negative. The same for the power, and the traction group. The traction group, we can see the current and the power, and the current for each feeder cable for every second. So it is very easy to analyze. We can also show the voltage of the traction group of the substation. In the end, last but not least, we also show the load diagram of the substations. In this case, we can see that substation I is above its limit. This is why this substation is overloaded, because compared to the limit, it is above. Okay, I hope that you like it, and see you in the UK Light Rail Conference.